Engineering is a problem-solving profession. The way it works is by constructing models. It's too expensive to run experiments at full scale in civil engineering where we deal with buildings and bridges and highways. So instead of full scale, we build models in the lab. We can also build models mathematically. So we might create a bunch of cause and effect relationships in our mathematical models so that we can make predictions about what actually happens in the world. And all these relationships, they have to be transferred to equations that create the cause and effect sort of functions of the model that are supposed to represent the real world. So we do that by extracting data from the real world, populating the model with the data. Then, once we've answered questions of the model, we suppose that the model gives us a reliable representation of the real world. So every model has a user, and the user is going to make inquiries of the model that it might be too expensive to make of the real world, and the model will provide them with output that they suppose corresponds to the world on which eventually they intend to act. As a result of their actions in the world, the user will have experience. So let's think of an example. We might, for example, have a model of a building, and we expect the relationship between the forces, that is the loads and the structural members of the building, to be as such and as such. We create the model with a computer. The user makes certain queries of the model and receives output, and as a result builds the building in the world. The building then is part of the user experience, and hopefully it withstands the loads in the way that the model expected. The model is always constructed by a modeler, and sometimes the user may not understand what the modeler intended for the model. That is, the user has certain goals that they bring with them to the exercise of the model. And they have a certain frame, that is, a way of thinking about the world, a way of interpreting the observations in their experience, what to pay attention to, what to emphasize, what to ignore. But the modeler also has goals. The goals might be to describe some part of the world. It might be to make predictions about a part of the world. It might be to make prescriptions, that is to say, what should happen in the world. So the modeler has their own goals, which aren't necessarily the same as the user, and the modeler, of course, has their own frame. Costanza calls this the pre-analytic vision. That is, it includes some sort of background understanding of the world. It includes some sort of preconceived beliefs about the way the world works. And of course, it includes biases. The whole point of the model is to emphasize some aspects of the world and ignore others. The model draws our attention to those aspects of the world that we want to focus on. And by its very nature, then, the model is going to be biased. The trick is to bias it in such a way that respects the modeler's goals. But sometimes the user and the modeler are not in communication. That is, the user might be trying to solve a certain problem, but the modeler might have had a different problem in mind. When you construct the model, the frame of the modeler is very important to understanding how the model is going to constrain the solutions. For that reason, anytime you go into any sort of engineering problem, you must understand what problem is it that you are trying to solve. Once you have this understanding of the problem, that's going to wind up being built into the model. Once you build it into the model, it means there are only certain types of solutions that can come out of the model. What I mean to draw attention to is that the problem and the solution get formulated simultaneously. If you say the problem is, public education, you simultaneously call to mind certain solutions. It's often the modeler that defines the problem and the user that is looking for the solution. The relationship between the modeler and the user might be transparent, especially when the modeler and the user are the same, or they might be different. For this reason, it's important for engineers to understand the inner workings of the models that they use, and especially to understand what problems are they trying to solve. Sometimes the world will surprise you. You thought you built a model to solve one problem, but you wind up with something that your model never predicted. When the user experiences surprise, that's when it's time to go back to the modeler and reconstruct a new model.